Hi, this is Mrs. Burlinghoff, and this is Geometry, Chapter 11, Section 6. We're covering arc lengths and sector areas in this section. Our first objective is to define an arc length. If we're going to determine and calculate an arc length, we better know what it is. The best thing to do is simply to review. We've already covered arcs in Chapter 9. An arc is an unbroken section of a circle. So for example, we see circle M here, which is colored in pink, and there are several points on circle M, and you'll notice that those points break the circle into what we call arcs. There's arc LX, which is less than 180 degrees. It's a minor arc. And then if you go in the other direction, if you start at L, go through A, and end at X, going counterclockwise, you'll see the other arc. So we have one arc from here to here, and we have another arc from L through A to X. And that's a major arc because it's clearly more than 180 degrees. So, having reviewed what an arc is, we will also determine that you can determine an arc length by taking a piece of the circumference. So here's the whole circumference of the circle. And remember, we have a formula. If we know that the radius is 15 millimeters, like it is here, then we can determine the length around the whole circle by plugging it into a formula. We don't have to wrap our measuring instruments around the circle. So if we're able to find the entire circle's length, the circumference, then certainly can't we find just an arc length, which is just a portion of the circle? That's one of the objectives here in this section. So now that we know that an arc is just a piece of the circle's circumference, we have a better understanding of what we're going to be doing. Okay, so our next objective here, we're going to define what a sector is because we're being asked to find the sector area. So once again, reviewing, here's the circumference. It's the distance around the entire circle. Here's the area of a circle. It's the region covered by it. In other words, the interior. And a sector, then, is a piece of the area. So imagine that the area is like a pie. When you cut a slice of pie out, you're cutting out a sector. And a sector is a piece of the area. It looks like a pie slice. Okay? So that brings us to our third objective, which is use formulas to find arc length and sector area. And we can do that. So the interesting thing is, this right here, 2 times pi times r, that's the distance around the whole circle, or the circumference. So the arc length would be, we abbreviate it with a lowercase l, would be equal to the portion of the circle we have, however many degrees out of 360, times the entire circumference, where x is the degree measure of the arc, or the central angle, because remember, central angles equal their arcs. And if we're going to find the sector area, we start off by finding the whole area of the circle, and then we can just find the sector area by taking a portion of the circle that we have. So however many degrees out of 360 that we have, take that fraction of the whole area. Remember, of means multiply. So our sector area, we'll just write in area here, is a fraction of the entire area. So let's try an example here. Okay, so we're going to find the arc length, lowercase l stands for arc length, and the sector area of a circle with a diameter of 10 inches, and the arc measuring 72 degrees. So here's our sector area formula. We're going to plug in 72 over 360, and we're going to multiply that by 2 times pi times r, which in this case is 5. If the diameter is 10, the radius is 5. Or you could just put in here 10 pi at this point. Okay? And then when you multiply this out, remember, the first number here is a fraction. You need this one to be a fraction. Just give yourself a denominator of 1. When you multiply 72 times 5 times 2, you end up with, I believe, 720 times pi. And then 360 times 1 is 360. And then you simplify this fraction by dividing the 360 into the 720, and you get 2 pi. It's really just 1/5 of the circle. If the whole circumference is 10 pi, 72 goes into 365 times. So we're really just finding 1/5 of the circle. Just plug it into the formula, it'll work for you. See if you can find the sector area on your own. You should get 5 pi for that answer if you plug it into the formula properly. And that's the end of Section 5, Arc Lengths and Sector Areas.